magnetic relaxometry. This is going to give me a functional image. It reminds me of a PET scan, but without the radiation when I take a look at what we're doing. So no radiation, it's non-invasive. It works with the current workflows. It's really a platform technology, and I'll show you what I mean by that, but the platform technology, you know, everyone looks at something like this as the platform. The platform in my mind is the nanoparticles themselves, the SPIOs, super paramagnetic iron oxide nanoparticles. And I'll show you what that means. The way these things work is we have these little nanoparticles, and then we functionalize these with antibodies. And we can put different antibodies in. We've got an antibody right now for HER2 positive breast cancer. We've got other ones in the works for prostate cancer and ovarian cancer. So they'll attach. And when they attach, their characteristics change, which is what we're after. If I had just a PET imaging agent that I functionalized, you know, they would attach, but I would still have the circulating antibodies in these, whatever I use from a molecule still in your system. And so I have this background, plus I have whatever's attached. So I've got to try to get above that. It's a large molecule. It takes a while to clear your body, so it's a difficult problem, but it can be done. But you're talking radiation. What happens here is these nanoparticles will attach if they've been functionalized to that cancer. If they're unattached, they behave different. And how they behave is, if I put a magnetic pulse into these things, a quick one, these SPIOs, or these nanoparticles, magnetize. And then they demagnetize when the magnetic field goes away. If they're bound to a cancer, they demagnetize slow. If they're unbound, they demagnetize fast. Actually, it's more like that. So right away now, I have a way of differentiating whether it's attached or unattached, which now gives me a functional image map. So what I find fascinating about this is I have a way of doing functional imaging without the radiation in a very precise way.